Okay, so as said earlier, this is the third kickoff of today's session on the concepts by disciplines. So we've covered those for geotechs, we've covered those for excavation support lining, and now we have this one meant to cover concepts for systems. Again, we have altogether between around 260 new concepts and properties. Therefore, did we need to make a selection for all disciplines, and altogether we probably have around 40 concepts to cover and to present to you. And the ones for systems, this sub-selection that we made, we are going to be presenting to you in the coming 30 minutes. So I think I should leave you again the floor, Lars, so that you can take people by hands through those concepts in question.
Okay. My mouth is almost getting a little bit dry after all talking. Okay, so we have in previous sessions here talked about the geosciences domain and excavation domain, and now we go into the systems domain. And as Michel mentioned, we have to select a number of concepts which we have described here, but maybe I should start. I forgot that in the previous sessions. You see, we have this other example clause down here, because what we are doing here is an example on fire protection. If you don't have support for that, you can, of course, come up with your own example, and we'll try to come up with tunnel-specific instructions for that. So don't be sort of discouraged if you find that this particular example doesn't suit you or your software. So again, we are building incrementally on what we have been doing in previous sprints up until sprint 2.3. And we add a couple of new concepts here, besides using entities that are sort of specific to, in this case, the systems domain. Actually, the systems domain for tunneling, we have been able to reuse, I think, most of the existing entities that was already in previous IFC versions. Pretty good support for this. So you will see in our example here, I think actually all entities here existed from before in IFC. The only thing I think that we added is the actual fire protection system. So what we are trying to do here is to create a system then where we have pipes, we have a sprinkler, we have a sensor, and we have ports. And ports is then an important concept for describing, let's call it topology in this case. So the way, so using these concepts, you can actually convey, for example, the flow or of water, or other. I mean, since we are dealing now with a distribution system, sort of media or something is distributed from somewhere to somewhere. So what we have here is a pipe segment, should be contained as all elements. In this case, in the tunnel or tunnel part, which you have from before, if you have participated before. Tunnel and tunnel part are then facilities and facility parts, of course. the pipe segment should have some type of body geometry. You can use volumetric representations from Sprint 2.3, but here we also added, because that might be good for representing pipes. You have body swept solid geometry and body advanced swept disc solid polycurve geometry. And there is actually, I managed to create, I don't know if it's entirely correct yet, but I managed to create an example file which is in a pull request where I actually used just a simple extrusion of a profile which has an outer and an inner radius. So you actually describe sort of the material of the pipe there. The pipe should have a local placement and relative to its containment, as always. We should associate a material, and in this case, is it the material layer set in that case? So you have the concept template here. You associate material layer set, which then is a set of material layers with thicknesses and materials. I wonder if this not should be a material single. We'll have to look into that. Maybe it's a copy and paste thing here. Anyway, it should nest ports. So we have the port nesting concept template here. So the ports actually describe sort of connection entities. So these are then, let's say, points on the pipe which can be or are connected to ports on other elements. So we describe the topology that way. So we use the IFC rel nests and we use the IFC distribution port, which we then nest into the distribution element. The distribution element in this case is the pipe segment, and you nest the ports, and you actually have a table 599 in the usages section for pipe segment. We have the concept usage here, and we have the port nesting concept here in table 599. So there you see that you should have the port name, inlet and outlet, depending on in which end you are. Sink and source actually then describes the way the media, in this case water, flows. Sink is actually where the water comes in, and source is where the water leaves the pipe. And properties, we have the PZ pipe segment type common that we should attach to the pipe segment. Then we have a pipe fitting, sort of similar thing here. Nothing particularly different about this from the pipe segment, but it's a fitting in this case. So sort of the same structure should be contained, have a geometry, placement, material, properties, and it should nest its ports. And in this case, for fittings, you have a table again, 594 in the for pipe fitting in the usages section, which is a little bit more complex here. So you see predefined type, port name, inlet, outlet, flow, sink, source. So it's the same kind of principle. So where the water comes in, it should be the sink, and where the water leaves the fitting, it should be source. So it's all described here. And then we have a sprinkler, which is a fire suppression terminal. And so the concept of a terminal is then sort of the end of this whole chain of distribution elements. So here, so this is the thing that terminates the whole thing. So we have a sprinkler contained in tunnel or tunnel part, body geometry, local placement, and this should also nest ports. So you have another table here, 640, fire suppression terminal. And we have the description of how to use the port nesting concept for a sprinkler here. And then for IFC distribution port, that should then to actually convey the topology, the ports should be connected to other ports to actually describe the connectivity. So we have the, let me see, where do we have it? Port connectivity concept template, where you have distribution port on both sides, and then you use the IFC-rel connects ports entity here so you can sort of connect the ports in the pipe segment to the or the source port of the pipe segment to the sink port of the pipe fitting and so on. So in that way, you describe both the connectivity and the sort of direction of the flow as well. And here we say no geometry, no containment, and we have a property set connected to the port as well. And you can look into this. It describes things like temperatures or pressures or things like that. And then since we are in systems, we also want you to group all these elements into a fire protection distribution system. And as all systems, this should be declared in IFC project, and it should group the elements above. So there we have a small fire protection system then. And oh, I actually forgot. We have also a sensor here, which actually controls all this. So the sensor itself should be contained in tunnel part, should have body geometry, local placement. It should also have ports, and you have a table 318 with a link. And then it should also have this flow control relationship with the sprinkler. So it actually should sense that there is a fire and should actually describe that it actually controls this sprinkler. So we can look at this as well. Where do we have it? Control flow. So you have this relationship between a distribution control element, which is the sensor in this case, and the IFC-rel flow control elements association, and then the distribution flow element, which is the sprinkler in this case. So you can sort of convey the functionality also of this sensor component in this system. And there is an example file that I managed to create for this, which is still in a pull request, and I don't know yet.
Losing you again.
Okay. Yeah, it happens.
Example
Yeah, well, I just said that I have there is an example file in a pull request. So when we have the checker ready, we will be able to verify either the checker or this file. But anyway, we will have an example file available also. And again, to repeat, if you have another good example of some kind of a tunnel-related system, then please come forward with that.
Thank you, Lars. Thank you much. Just for those who joined the call after we had started, this is what we've presented here is a subset. It's only a subset of all the concepts that make up the systems part of IFC for tunneling. And this is a subset that we selected. But as you've understood, for this one particular fire protection system, it covers things from start to end when it comes to the functionality, the domain functionality. And of course, then the rest of the concepts related to the other systems are parts of the model and are parts of the documentation and can be accessed through the same GitHub interface. Of course, up to you to investigate. And but again, the way those concepts are to be implemented for those other systems is quite similar to the way these here are to be implemented. So these are very good examples. Okay, with this, we can open up for some questions. We have a few minutes. Thanks again, Lars. Thanks again. Any questions? Any comments? No? Well done, very good.
I mean, you can also post questions to any of the previous documentations that we've described. So if you also have questions for geotechnics or for excavation lining and support, please do raise your hand or unmute yourself and pose the questions. And thank you, Lars, for walking us through all 3 readmes. You definitely deserve a cup of water, right?
Yeah, I think I need some water now.
So I assume everybody's already programming. That's why everybody's so quiet.
Absolutely. It looks like as we moved forward from since early this morning, we've been clearer and clearer, and we are therefore getting less and less questions. So that's good. That is good. Of course, this is a lot of information we are providing you with this morning, but again, support calls, and of course the platform itself, the GitHub platform, is available for you anytime. Example files as well. I check you very soon. Documentation regenerated very soon, coming hours. And the support calls that we offer you every Thursday morning and evening, that will carry on until the end of September. So we hope that by that time, you will have gone through all those concepts that we've selected, but as well for your own business through the concepts that are not in there, but that are part of the conceptual model again. Any other final comments that Lars, Stefan, Sergei, you would like to add?
I would just like to add something
Please.
shortly at the end. We're also looking at a couple of schema changes this time around in the documentation. So the toolkit which the checker uses has to be updated also, and the rules, the where rules, and the functions that are then used, and also of course the constructors for the entities are all different because we are using derived attributes to construct, for example, voxel data and so on. So I would just like to warn everyone that since this is automatically generated, the toolkit and the checker, if there are any issues that you find, please let us know as soon as possible so that we can polish the generation.
Yep. And maybe Stefan, a recommendation in terms that we can pass on to our developers friend here in terms of submitting files. Do they need to document somehow whether the submission they may cover more geotechnics concepts rather than excavation concepts, rather than systems concepts? Is that something we expect people to document when submitting?
Yeah, it's a very good question. So as the pull request template already foresees, is that you list what you think you support, you have included in your files. It also enables us to make a more streamlined review process of your files. So if you say that you expected to have included, for example, the fire protection system, then we will know, well, you know, if we don't find it, then perhaps something went wrong somewhere. But, you know, just some sort of bullet points documentation as to what you think you've included. And the checker, as it currently stands, will be one to rule them all, because there are enough, let's say, applicability gates where, of course, if you will not include the system, the file will still not be changing, will still not be necessarily failing the whole thing. And also in this manner, Lars, if you scroll a bit down in exactly this markdown that you have open, to reiterate. So if you have any other examples that are perhaps easier to be exported from your softwares, please do approach us at one of the support calls, or even shoot us an email, and we might give you some more instructions on a different system, but then also the checker will need to be updated accordingly in order for you to have some feedback there. This applies, I believe, also to other READMEs. I'm not sure, Lars, have we included this in other READMEs?
Yes,
I
think we
think there
have
should
this.
be, yes. Yeah.
Yes.
So please do, if you have something else that you would like to share with us, of course, more than welcome. And the goal is to, you know, test the schema, test the documentation, see where we perhaps need to polish it a bit, and also for you to explore the IFC in a more, let's say, guided manner.
Indeed. And maybe a last comment on my part is given that with this Sprint 3 concepts, we are building up on the previous concepts that we covered in Sprint 1 and Sprint 2. If you are somehow late or a bit behind on Sprint 1 and Sprint 2 concepts, some of these you will need for Sprint 3. Do not hesitate to ask questions as well on those concepts that we covered earlier on. We are not closing the door, so you can add, you know, the support calls. You can ask for any clarification on the on concepts from the previous sprints as well. Okay. I think that with this, if no other comments or questions, I think we can adjourn this one call. Thanking you again for your time this morning and your commitment to this project. We hope all this is really informative to you and will speed up your implementation work, though we do realize that this is, of course, quite significant activity for you to undertake as of now, but we'll be there to support you. Let me please thank again Lars, Stefan, Sergey for putting all that materials together in such a short time frame. Looking good though. So with this, I wish everyone a good day, a good night, and we'll be in touch, and we'll speak for each other again at the next support call Thursday to come, Thursday next week. Cheers. Bye-bye, everyone.
Thank you all.
Bye.
Bye-bye.
Thank you. Bye-bye.
Thank you. Bye.
Bye. Thanks.